Hello everyone, CAT 2024 DILR section slot 2. Let's discuss some really good sets. First set, it says the above is a schematic diagram of the walkways, not above, the side, indicated by all the straight lines. These straight lines are walkways. This one is also walkways and lakes, 3 of them, each in shape of rectangles shaded in the diagram. So this one denotes a lake, this one also denotes a lake, this one also denotes a lake of a gated area. Different points on the walkway are indicated by letters A through P. So these are the notable points on these walkways, with distances being OP is equal to 150. So this OP is 150. ON is equal to OM is equal to 300 meters. So we can say this distance is 300. This is also 300. ML is equal to 400. This distance is 400. EL is equal to 200. DE also equal to 400 meters. So basically, we can find each of the distances here, right? Now it says the following additional information about the facilities in the area is known. The only entry exit point is at C. C is the only entry and exit point of this gated area, gated society. Means someone from outside can enter through point C and can exit through only point C. There are many residences within the gated area. All of them are located on the path AH and ML. AH and ML. So these are the residences. The residences are on these paths, with 4 of them being at AHML. So these are the fixed residence, the location of those 4 of those residences. The post office is located at P. Post office is located as P, and the bank is located at B. This is given. These are the information that has been given. Now let's check the questions. So each question, you can see the length of the question, and you can understand that each question is based on a proper condition, a proper information. So definitely, although all the sets in DILR CAT 2024 were easy to moderate, but whenever you see that each question has some length, some condition, then you should avoid it using as your first set or second set, okay? But now let's discuss it. First question, one resident whose house is located at L. Located at L. So house is located at L. Needs to visit the post office as well as the bank. What is the minimum distance he has to walk starting from his residence and returning to his residence after visiting both the post office and the bank? So this guy can go to bank, can go to post office, or this guy can go to post office, then bank, and then returning to this. How can we minimize the distance? Now remember, first of all, let's write down all the distances which are given. So here it's OP is 150, ON is 300, NM is 300, this distance is 400, EL is 200, this distance is also 400. So can we say that all of these are rectangle, this is a rectangle, so Kn will also be 400. In that case, using the Pythagoras, we can say OK will be equal to 300 square plus 400 square, which will be 500 square. So OK, length of OK will be 500. Similarly, the length of GI. So IJ is 150, GJ is 200, can we say that ij will be 250? Now, why am I finding these distances? Because we need to find the minimum distance. Right, now think about this. If someone is going from L to P, so he will have to go through this point, like he can go from L to J, then O, then P, or L to I, then P. But if he goes from L to K, K to O, so he can avoid this distance or this distance. 400 plus 300, 700. Instead of 700, he will have to walk only 500. Right? Now, from P, he can go to bank B. So, P to I to G. He can go to G from I to J, J to G, and then B. But what we need to do is we need to cover these distances. Or you can take the opposite, that he is going to bank first. From bank to coming to P. So, B to G, G to I to P. Then returning to L. So, P to O, O to K, K to L. But the point is to cover this distance. Now, in any way, if you calculate the total distance, it will be same. So, let's calculate it. So, he is going through this pathway from L to K, K to O, O to P. Okay. And then from P to I to G, G to B, B to C, and from C to L. Either he can go from D to L or C to K and then L, doesn't matter. Both of these distances will be same. So what we can say the total distance will be. So this is 300. This is also 300. This is 400, 200. This is 300. This is 500. This is 150. So let's calculate it. 300 plus 300 is 600 plus 400. 400, 1000, 1200, 1500 plus 500, 2000 plus 150, 2150, and this is also 400. So 2550, 150 is not taken because we will need to take 250. So 2550 plus 250, 2800 plus this 400. So a total of 3200 plus 300, a total of 3500, right? Or I guess there should be, we have added this 300 and 300, so we don't need to add it again. So this will be a total of 3200, right? 300 plus 300, or you can also calculate it starting from L. So 300 plus 500, 800 plus 150, 950 plus 400, 1350 plus 250, 1600 plus 400, 2000 plus 600, 2600 plus 600, 3200. So our answer is option D. All right. Now next question, question number 2. One person enters the gated area and decides to walk as much as possible before leaving the area without walking along any path more than once. So, no path should be repeated and always walking next to one of the lakes. Note that he may cross a point multiple times. How much distance will he walk within the gated area? So what should we focus on? That he is able to cover all the boundaries of all the lakes, if that is possible, without repeating any boundary, then we should get the answer. Doesn't matter the direction, but if you check it, we can enter from D, going from C to D, D to E, then here, okay, and then going covering this one, and then returning to this one. This will be the direction. Now, in this case, you can see that all the boundaries have been covered, right? So we don't need to think twice here that is there any other possibility, better way, because all the boundaries of all the lakes have been covered. You cannot walk twice on any pathway. So that's it. That's it. Now, what do we know about these distances? Again, this is 300, this is 400. So perimeter of this rectangle will be 400 plus 300 into 2, which is 1400, and this one FCDE is also 1400. So we get 2000, 2800 plus this is given, which is 200, and this is 300. So 500 plus 500, 1000. So total distance covered by this person is nothing but 3800, which is option A. Okay. Now, third question, it says one resident takes a walk within the gated area starting from A and returning to A. Starting from A and returning to A without going through any point other than A more than once. What is the maximum distance she can walk in this way? So what we can say, that no point should be repeated, right? No point should be repeated. That means we cannot walk twice on some pathway. Like if you are going from A to B and B to A, so B is being repeated, right? So, or A to C, and then coming from C to A, B is being repeated. So in that case, what should our target be? Such that no pathway is repeated, no point is repeated, and we need also to maximize the distance. So can we say, in that case, our target should be to go through every point in this diagram. If we are able to do that, then we will able to cover the maximum distance possible as per the given condition. So what should be the way? Now there could be multiple ways. There could be multiple ways. See, one way is we can go from A to GH, GH to J, then I. See, I'm not going from A to H and then I, because then I will miss this part. So I to P, P to O, and then O to J. Now J is being repeated here, so let's ignore that, right? So I to N. If I go through N to K and then L, I will miss M. So let's go to M, then L, then go to K, then here, then here, then here, and then CBA. Are we able to cover all the points? I guess yes, we are. We are able to cover all the points. Now, if you check the distances, what is the total distance covered? So this whole distance is 300 plus 300 plus 150. This is 750, right? And this whole distance is 400 plus 400 plus 200, which is 1000. So in that case, we can say if I take this one, this one, this one, so I have covered 1000. If I take this one, this one, this one, I have covered 750. Then again this one, and this one, I have covered 1000. This one, this one, this one, I have covered 750. So a total of 1000 plus 750 into 2, 3500 plus the extras. What are the extras? The extra distances covered is this one, this one, this one, and this one. So this is 150, right? So 150 into 2, 300 plus 300 into 2, 600 means 900. If I add 900 here, I am getting 4400. But the question is that maximum? We are able to go through all the points, but is that maximum? Can I start with A to B and do something like that where we are able to cover all the distances? Now think about this. If I am able to cover this distance twice, this distance twice, instead of that, if I am able to cover this distance twice, so I will get more distances, right? So instead of covering this, let's try, I'm not sure, but let's try to cover that distance. Let's check if we are able to get more distance, like from A to B, B to G, G to F, F to C, C to D, and then D to M, M to N, N to K, J, O, P, I, and yeah, A. Are we able to cover all the points? See, initially while solving this question, we had discussed that we need to cover all the points. The distance will take care of itself. Now, that can be done in how many ways? That doesn't matter. So there was one way. This is the second way. So let's check this. What is the distance covered here? So again, 1, 2, 3, a total 1000. 1, 2, 3, a total of 1000. 1, 2, 3, 750. 1, 2, 3, 750. What is the extra? So this is 3500 already, plus the extra portion, if we check, is this one, this one, this one, and this one, right? These four distances make the difference. Each of them is 400. So 400, 400, 400, and 400. So add 1600 now. So if I add 1600 now, we are getting 5100. And this is the maximum, right? So that should be our answer. So again, the target was to cover all the points. That can be done in multiple ways, but two basic way. One was going through A to H, one was going through A to B. And in those cases, we got two different distances, but the maximum is 5100. That is our answer. Question number 4, it says, visitors coming for morning walk are allowed to enter as long as they do not pass by any of the residents. Where are the residences? A, H, L, M. These are where some residences for sure. Now it says, and do not pass by any of the residences and do not cross any points except C more than once. What is the maximum distance that such a visitor can walk with the gated area? So someone is entering with C, exiting with C. They should not go to point L or M or H or A. What will be the maximum number of distance covered by those persons? So again, what should be our target is to cover all the remaining points. All the remaining points. So in that case, see, do not cross any point more than once. So we will try to cover as many as points possible. So starting with C, we can go to F, but then to cover D, we will have to go to E and then D. That's the end of it. So we will start with D, then we will go to E. Now from E, you cannot go to L, so you will have to go to F. From F, you can go to K, you cannot go to L. So from K, let's go to N. From N, let's go to O. From O, I can go to J. Then I can go to I and then G. But in that case, P will be skipped. So what we can do, that I can go to P, and then I can go to I, then J. I cannot go to H, then G. From G, B and F. So these are the distances that is covered. All the points have been covered. So there were two ways. Either a person can go from C to D or a person can go from C to B. But to maximize the distance, we will have to go through all the points, and that's the only way possible. Now let's try to calculate the total distance. What will be the total distance? This is 300, 300 plus 300, or maybe let's count it while we are going. So 300 plus 400, 700 plus 300, 1000 plus 200, 1200, this is 400, 1600 plus 300, 1900 plus 150 and 150. So 2200 plus 400, 2600. This is again 200. So 2800. This is 400. So 3200 and this one 3500. So total distance which is covered is 3500 maximum, and that is our answer. All right. I hope that is clear how to handle these type of situation, that how to maximize. You cannot go through a point twice. So in that situation, what do? We try to cover all the points. That's it. That's the way. If there are multiple ways, check them, but there lies your solution. Okay. Now, let's go to the next set. An online e-commerce firm receives daily integer product ratings from 1 through 5 given by buyers. The daily average is the average of the ratings given on that day. The cumulative average is the average of all ratings given on or before that day. The rating system began on day 1 and the cumulative averages were 3 and 3.1 at the end of the day 1 and day 2 respectively. The distribution of ratings on day 2 is given in the figure given below. So this is the line graph provided regarding the distribution of ratings in day 2. Now let's try to understand that this denotes, x-axis denotes number of buyers and y-axis denotes ratings. What does that mean? That there were 5 buyers who gave a rating of 1. There were 10 buyers who gave a rating of 2. There were 5 buyers who gave a rating of 3. And 20 buyers who gave a rating of 4. And 10 buyers who gave a rating of 5. So these are the information regarding day 2. Now next it says the following information is known about ratings on day 3. So some information has been given. So what do we want? We would like to make a table where we can use this information and calculate something easily if asked. So let's take day 1, day 2 and day 3. Now this is all about buyers. Okay, we are talking about ratings, we are talking about buyers. So I am writing about buyers here on each day. This is ratings. So something like this. 5 different ratings, right? So rating 1, 2, 3, 4, 5. Now what will be the average? And there is also cumulative average. So let's write that down also. Again, now you can see we can put all the values here, right? First of all, let's start with day 2. How many buyers gave a rating of 1? So 5 buyers. How many buyers gave a rating of 2? 10. Then 5 here. Then 20 here. And then 10 here. Now it's given that the cumulative average is the average of all the ratings given on or before that day. And the rating system began on day 1. The cumulative averages were 3 on day 1. So day 1, there is no day before day 1, right? So the average and the cumulative average will be same for day 1. 3.1 at the end of day 2. So cumulative average at the end of day 2 is 3.1. Now in case of day 2, can we find the average? Yes, we can find. What will be the average? So 50 plus 20, sorry, 5 into 1, 5, plus 10 into 2, 20, 5 into 3, 15, plus 20 into 4, 80, plus 50, divided by total number of buyers, which is 20, 30, 40, 50. So this is divided by 50. So what do we get? This is equal to 50 plus 80, 130, plus 40, 170 upon 50, which is 3.4. So the cumulative average, sorry, not cumulative, the average on day 2 is 3.4. Now think about this, that on day 1 we have cumulative average, on day 2 we have cumulative average. So on day 1 the average is 3, on day 2 the average is 4, but the cumulative average, or we can say the weighted average, is nothing but 3.1, because this average is taking day 1 and day 2 together. So this is 0.3, this is 0.1, means 3:1. What does that mean? That number of people on day 1 is to day 2 is 3:1. Now check this. On day 1, how many buyers are there? We don't know, but on day 2, there are 50 buyers, right? So if on day 2 there are 50 buyers, can we say on day 1 it must be 150 buyers, right? So this is all about day 1 and day 2. We don't know this distribution for now. But let's check day 3. On day 3, it says 100 buyers gave product ratings on day 3. So total 100 buyers. The modes of the product ratings were 4 and 5. What is mode? So for any data, the value that has been there for maximum number of times is known as mode. Like if we say what is the mode of ratings on day 2, so it will be 20, because there are 20 buyers who gave rating 4, so maximum number of times. So we can say 4 and 5 are maximum as well as equal. So if this is A, this is also A. The number of buyers giving each product ratings were non-zero multiples of 10. All of these values are multiple of 10. The same number of buyers gave product rating of 1 and 2. That number is half the number of buyers who gave a rating of 3. So basically, if this is 2B, then these are BB. Now all the numbers are multiple of 10. So what are the values that we can consider here? Can I take B is equal to 10? So if I take this 10, this will be 10, this will be 20. Now these two are equal. 100 minus 40 is 60. 30 and 30 we can take. But if I take this 20, 20, 40, this will be 20 plus 20, 40, this will be 40, that is 80. That means these two will be 10, 10. Those are not maximum. So that is not correct. And we don't need to check further. These are the actual number of buyers on day 3 who gave ratings 1, 2, 3, 4, 5 respectively. So what is the total number of buyers? That is already 100. Now can we calculate what will be the average here? Think about this. 10 into 1, 10. 10 into 2, 20. 20 into 3, 60. So let's add these values. 10 into 1, 10 plus 20. 20 into 3, 60 plus 30 into 4, 120 plus 30 into 5, 150. And this will be divided by 100. So this is equal to 30 plus 60, 90 and 270, 360 up by 100. This is 3.6. So the average rating given by the buyers on day 3 is 3.6. So what will be the cumulative average? Can we find the cumulative average? So while finding the cumulative average or weighted average, instead of actual values, we can also use their frequency, right? Ratio of frequency is 150, 50 and 100. So we can take 3:1:2, right? Now we can find the average, which is 3 into 3 plus 3.4 into 1 plus 3.6 into 2 divided by 6, which gives us 9 plus 3.4, 12.4 plus 7.2. 12.4 and 7.2, 12.6, 19.6 divided by 6, which is equal to 9 point, or we can directly divide this. This will be 9.8 upon 3, which is equal to 3.2 times and then 20, so 6 times approx, right? 3.26 approx. So let's write it down here. 3.26 approx. This is the cumulative average on day 3. Now, let's try to solve the questions. How many buyers gave rating on day 1? So we know this, right? 150 buyers. The number of buyers rating is 3:1 on day 1 and day 2. What is the daily average rating on day 3? So that is 3.6. Option A. What is the median of all ratings given on day 3? What is median? Median is if some numbers has been given and if you arrange them into increasing order, then whatever number comes in the middle, that is your median. Or if there is not one number which is in the middle, if total number of numbers is even, then the average of the two middle number will be your median. So in that case, in case of day 3, what do we have? We have rating 1 10 times, rating 2 10 times, rating 3 20 times. Arrange them. These are 40. What do we want? The 50th and 51st. So 30 buyers have given rating of 4. So the 50th buyer and 51st buyer must have given rating of 4 if we increase them as per their rating. So the median will also be 4 here. Which of the following is true about the cumulative average rating of day 2 and day 3? The cumulative average, so let's write it down. Day 2, the cumulative average is 3.1. Day 3, the cumulative average is 3.26. The cumulative average of day 3 increased by more than 8% from day 2. So basically we need to find what is the percentage increase. So what's the increase here? From here to here, it's 0.16. So 0.16 divided by 3.1 into 100. So this will give us 0, 0. This we can cancel out. This is 160 upon 31, which is equal to 5 times 155.1 something, right? Okay. So it's not more than 8. The cumulative average on day 3 decreased from day 2. That is also not correct. It has increased. The cumulative average on day 3 increased by a percentage between 5% and 8% from day 2. Yes, this is 5.1 something percent, right? So option C should be our answer. Let's check the D as well. The cumulative average of day 3 increased by less than 5%. Definitely wrong, right? So this was a really good set. If you are familiar with average, weighted average, or in terms cumulative average, right? So this set was out of 5, I would say it was 2 to 5, 2 by 5, okay? And this, the ideal time to solve this set, I guess it should be 6 to 8 minutes. That's it. Once you get all these values, once you make the table, this set is very easy. Questions are not challenging. There is nothing much to do once you are done with all the information. The numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 are placed in 10 slots of the following grid based on the conditions below. So these are the 10 slots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 slots, and there are 10 numbers from 1 to 10. We need to put these numbers into these 10 slots with some conditions. What are those conditions? Numbers in any row appear in an increasing order from left to right. From left to right, they are increasing. Number in any column appear in a decreasing order from top to bottom. Top to bottom decreasing means, can we say bottom to top? It will be increasing. Okay. Now 1 is placed either in the same row or in the same column as 10. So 1 is with 10. Neither 2 nor 3 is placed in the same row or in the same column as 10. So 2 is not in the same row or column as 10. 3 is not in the same row or column as 10. Neither 7 nor 8 is placed in the same row or column as 9. So 7 is not with 9. 8 is also not with 9. 4 and 6 are placed in the same row. 4 and 6 are placed in the same row. Okay, same row. Now, where do we start? So, as soon as I realized that numbers should be increasing in left to right, numbers should be increasing from bottom to top, 10 is the biggest number. I realized that doesn't matter in whatever row 10 is in, it must be at the rightmost position, means in any of these four. And then again, if we talk about any of the column, okay, in any of the column, it must be in the top position, right? So any of these four. So only intersection point I got is this position, which is 10. Now, as numbers are in increasing order, 8 and 9 must be immediate to 10, right? Now 9 and 8 cannot be in the same row or same column, but 9 or 8 must be immediate to 10 because there is no other way. If you put a slot between 8 and 10, there must be 9 between those to make the order correct. But 8 and 9 cannot be in the same row or same column. If you put a slot between 9 and 10, there must be a number in between which is greater than 9 and less than 10. There are no such numbers. So 9 or 8, the position is fixed. Now think about this information that 1 can be here or here, because 1 is the smallest number, so 1 can be here or here, right? Then 2 and 3 cannot be in the same row or column as 10. So 2 cannot be here, 2 cannot be here, 3 cannot be here also. So what are the possibilities? We have 3 places left. Where do we put 2 or 3? Can I put 2 here? I cannot put 2 here because then this number should be less than 2. This number as well should be less than 2. There is only one such number, which is 1, but 1 should be either here or here. So 2 cannot be there. Can I put 3 here? If I put 3 here, then this number must be 3. This number also must be 3. There are 2 numbers which are less than 3, 1 and 2. But 1 is already here or here. So this is also not possible. There are 2 slots which are less than 3, which is not possible because we have only one number. That means at this place, 2 or 3 cannot be there. So 2 or 3 can only be here or here, right? Now, it's given that 4 and 6 are in the same row or same column, right? 4 and 6 are in the same row or same column. So what row? Sorry, 4 and 6 are in the same row. Which row should I choose? So if I am not sure about 1, let's remove it for now. 4 and 6 cannot be in this row. Not in this row. So there is only one possibility for 4 and 6. So 4 and 6 can only be here and here. Then I know that 1 will be here. Now think about this, that 9 and 7 cannot be together. So this cannot be 9. 7 can only be here. So 9 must be here, 8 must be here, and 5 must be here, right? Now can I say that 9 is here, 10 is here, 8 is here, 7 is here? Now each row numbers are in increasing order, each column numbers are in increasing order, and all the conditions are satisfied, right? So we can now solve these questions very easily. What is the row number which has the least sum of numbers placed in that row? So it's definitely fourth row, right? Where only one number is there, which is 1. So answer is 4. Which of the following statement must be true? 10 is placed in a slot in row 1. So this is true. 1 is placed in a slot in row 4. That is also true. That means both 1 and 2. Which of the following statements must be true? 2 is placed in a slot in column 2. See, 2 can be in column 2 or column 3. We don't know that. Similarly, 3 is placed in slot column 3. We don't know that. So, neither 1 nor 2 is true. For how many slots in the grid, placement of numbers cannot be determined with certainty? 2 slots where we have 2 and 3 numbers. What is the sum of the numbers placed in column 4? Column 4, this one, right? So 10 plus 8 plus 8, it's 26. So our answer is 26 for this question. So you can see 1, 2, 3, 4, right? 1, 2, 3, 4, 5. 5 questions on this set. Amazing, right? This set was certainly a set that you should attempt when you start DILR section in CAT. Okay, this will boost your morale and you can achieve whatever you have targeted in CAT exam and DILR section. Okay, thank you.